Today I will be talking about intermolecular forces and more specifically London dispersion forces. If you're new to intermolecular forces, be sure to check out my previous introductory video. So, what's an atom made out of? It's made out of protons and neutrons in the center with electrons orbiting that center. Just like how the Earth orbits the Sun, the electrons orbit the protons and neutrons of an atom. Above is a simplified representation of an atom. We will represent the center by this image over here. The circle around the center represents the orbital path of the electron. It is the spots where the electron would generally be while it is orbiting the center of the atom. I'm going to represent the electron as my pink pointer over here. Now I will demonstrate the orbiting electron to you. Of course, my mouse doesn't perfectly line up with the circle, but that's okay. Hopefully you understand the general idea that electrons will orbit the center of an atom. Let's freeze time for a moment now. Let's look at where the electron is when we froze time. This will now represent the electron. So, what do you know about an electron? It carries a negative charge. So let's represent that by drawing a minus sign. Pay attention to the position of the electron. It is on the upper right side of the atom's orbit. Remember, an electron carries a negative charge. This means that the upper right side of the atom will have a more negative charge than the lower left side because the electron is on the upper right side. In other words, the lower left side of the orbit will have a more positive charge than the upper right side. So let's represent that by drawing a plus sign. What do you notice? You should notice that this atom has a dipole, that it is polar. This is important because, remember, an intermolecular force is caused by the idea of opposites attract. Because this atom is polar, it will be able to attract a molecule of the opposite charge. Before we get more into that, something important to consider is that this charge does not last forever. In fact, it lasts for a very short amount of time. We would say that it is an instantaneous charge. Why is that? Remember, the electron is orbiting the atom. It doesn't stay in this position forever. I'll show you what I mean by giving the electron more time to orbit the atom. Again, pretend my pink pointer is the electron. We will freeze time again. What do you notice about our electron's position now, as opposed to its position previously? It's in a different spot. Remember, an electron carries a negative charge. That means that the lower right side of the atom will have a more negative charge, or that the upper right side will have a more positive charge. Now, this is different than what we saw earlier. Let's compare both our atoms side by side. To the left, we have the electron as we first saw it. On the right, we have the electron as we just saw it, which is at the lower right side. The electrons in an atom will always be moving, therefore the locations of the negative and positive charges will always change. Remember, opposites attract. If we pretend that these two are separate molecules, there will be a force of attraction here, due to the concept that opposite charges attract. This is what's called a London dispersion force. Because the electrons do not stay in one spot and always move, we say that a London dispersion force is an instantaneous dipole, that it only occurs for a split second before changing. Please understand that there is usually more than just one electron influencing the dipole movement, and that it is actually much more active and chaotic. Now that you understand how a London dispersion force works, I will be moving on to the concept of polarizability. Polarizability is essentially the tendency for a molecule to become polar. That can be a bit of an abstract definition, so I'll explain using pictures. So let's compare two molecules. On the left, we have the Lewis diagram for methane, and on the right is the Lewis structure for benzene. Now, just by looking at the Lewis diagrams, we can see that benzene is larger than methane. So, what does this mean? It means that a benzene molecule has more electrons than a methane molecule. Remember, polarizability is the tendency for a molecule to become polar through electron movement. If benzene has more electrons than methane, what do you think this says about benzene's polarizability compared to methane? Pause and take a moment to think about this. This would mean that benzene is more polarizable than methane, because more electrons would mean more electron movement, which would eventually mean more induced dipoles. So, benzene has a greater polarizability than methane. This would mean that benzene has more induced dipoles, which would mean that the London dispersion forces of benzene would be stronger than the London dispersion forces of methane. My question to you is, which would have a greater boiling point, benzene or methane? Take a while to think about this. I mentioned in my previous video that if you are melting something, you are breaking intermolecular bonds. If benzene has stronger intermolecular bonds than methane, this would mean that you would need more energy to turn solid benzene into liquid benzene than to turn solid methane into liquid methane. Therefore, benzene will have a greater boiling point than methane. I'm going to talk about one last thing. I mentioned in my last video that I would address nonpolar molecules. Nonpolar molecules do experience intermolecular attractions. After all, they are what keeps olive oil a liquid at room temperature. So, how can a nonpolar molecule be attracted to one another if they have no charge? What specifically is responsible for keeping the olive oil a liquid at room temperature? It's none other than the London dispersion forces I talked about earlier. Remember, a London dispersion force is caused by electron movement. Every molecule has electrons because every atom is made up of electrons. This means that every molecule will experience London dispersion forces, regardless if the molecule is polar or nonpolar. If a molecule is nonpolar, then its intermolecular forces will consist of only London dispersion forces. So, even if the molecule is nonpolar, electron movement will cause dipoles, which allow nonpolar molecules to have intermolecular forces between each other. That's all for now. I will be making more videos on this topic soon. Let me know any feedback or questions in the comments. Thank you for watching, and goodbye.